Hey everybody, Jeff AJ2A here. I'm playing with my robot, but actually I'm playing with just one part of it. I discovered that there was a TNC that runs off of, that uses one of these. This is an Arduino Nano. And with a couple capacitors, a transistor for push to talk, and 3-4 resistors, two capacitors, you can have a working TNC. So what my plan is with this lovely conglomeration. This is actually a combination of all of the TNC audio and stuff. I mean, there's only 5 wires connected to the breadboard from the Arduino. Everything else on it, there's like a beeper. There's like a beeper down here. And up here is the real-time clock, as an I2C real-time clock, and dangling down here, down here where my fingers are, right there, that is an accelerometer. Some of these wires are also for the ultrasonic detector, and some of these wires actually go to the Raspberry Pi, the Raspberry Pi zero W. This is a 0W that's controlling the motors and is the brains of the operation. The relays control the power to that. So this is working. It's connected to the TN. It's connected up to my ham radio computer up here, which has this here. I have X-Aster running, and I have this connected to the classic UV5R that has all of its labels removed because it's I don't say it's beat up, but it is what it is. And here is the output that we're getting from that. This is the cord for the TNC. So and we are getting data. Now there's more audio. I mean, if we looked at how much audio actually comes across it, this hasn't changed in the past 30 seconds. Oh, it just changed. Oh, it changed again. Ooh, that's a record there. But this has been going for a while, and it hasn't scrolled past this. So, and I have this all backwards, and I'm not using a selfie stick. So, and if we disconnect this audio, so we can hear the audio local. Okay, so I can understand. Like getting 2 in a row. Apparently there's 2 stations. 2 digipeters, APRS digipeters that come in better, but so let me switch this around. And we are getting more More things. Have we? Oh, and we have scrolled off of. We have scrolled past the old size. So I can't make it any bigger. I can't grab. Okay, so that's and I have tested that to make sure that it does actually transmit. So this is a KISS TNC, and there's Python software to configure it, and it does work with Python 3. I've verified that. Make sure you have a good cable. I had some cable issues. But so yeah, this is a little. I could probably. I don't want to send anything. I don't want to transmit. I mean, we're getting weather information from a weather station, so that's good. That's good. Good thing. So yeah, I'll probably end up making another one of these. I have some more breadboards coming, so that'll be nice. But it'll be integrated into the robot, and then I will start. Working on the actual protocol between. I mean, at first it's just going to be a terminal, pretty much. It's like it may just be a shell. I just may go with a shell. With the command line being my call sign, so I get a ID all the time. So because that's got to be figured into it is the 2-meter band and where I can put something. So what was that 14439 is in this new Oscar subband, which is where APRS is. And then yeah, and then so I'm gonna probably use somewhere in here, like 1457 or something. I could use one of these packet, because I know a lot of these aren't used here, but some of them are, so I can grab one of those if I wanted to. I just have to be a little careful because there is some packet. And I have my own packet station, or something. So I mean, that's kind of that's what this machine is kind of going to be doing. So yeah, so that's what I will be. That's what the plan is, to use this TNC to control that robot. You know. NASA usually doesn't use real-time driving commands, which I probably use at first. But hey, I will want to at some point have it toggle between a terminal mode and a have the TNC, if I can. Oh, it's just, so it's data. So it's like, it would still be AX25 data, but it would just be sending pictures instead of commands. So I don't have to switch. Like, I won't have to, like, in the future, I can use 440 megahertz. I can use 70 centimeters as a live video feed for that also, but this needs something bigger than this right now. So if I go putting more radios on this, there's already gonna be issues. I want to upgrade to these motors, but then I need to upgrade the chassis. I need to upgrade the track. So I'm gonna have to figure out. I'm outgrowing this really quick. Saddlebags? That may be a way to do this. Just to because the battery isn't on there. The battery is a DeWalt battery that sits in like that. So it's as low as it can get, but pretty much it's pretty much as low as it can get. So without dragging on the ground, because the bottom of this drags on the ground, which may want me to consider changing battery types. But this whole track situation is just kind of janky anyway. It's not very good. I'd rather have a suspension. It's like wider, a little bit wider, a little bit like more shoebox. This is smaller than a shoebox, so I kind of want like shoebox-ish size, I think. So I'm gonna be looking at some stuff to 3D print as far as that goes. But the TNC, I'm happy with the TNC. We're getting good TNC data, so that means that the next thing is to connect this to the Raspberry Pi on the robot and see if I can get a shell. Maybe I'll make a video of that. AJ73, AJ2A.